So, good afternoon, everybody, and I'd like to welcome you to the September 2024 Indicator of Behavior Subproject meeting as part of the Open Cybersecurity Alliance. My name is Charlie Frick. For those that might not know me, I am the chair of the Indicator of Behavior Subproject and your host for today's meeting. I come from Johns Hopkins Applied Physics Laboratory, and I know it's been a few months since we had our last one of these, but what I'm hoping to do is start us off with our technical talk for the meeting. We have, I think, some interesting topics to share with you guys on some network behavioral analysis tools and how we incorporate those into the IOB construct, along with some ideas about where we'd like to take some of that capability next. After that, we have a few news updates for the project that I'd like to share with the group and have some time for some general discussion before we adjourn. So with that said, I thought we'd dive right into our technical talk for the meeting. And this is a combination between myself and Mr. Carter Bullard. We'll be talking about using the indicators of behavior design to represent dynamically identified network behaviors. But before we dive into the IOB portion of this, Carter's graciously agreed to kind of help remind some of us, and for those that might be looking at this video later on YouTube, who haven't seen some of our previous meetings, to give us a little background on Argus and talk a little bit about network behaviors and behavioral detection so that that'll help us switch over to the demo with IOBs. Carter, if you're ready, I'm happy to hand the microphone to you and stop taking up your airtime.
I didn't know I was going to start.
Oh, I thought you wanted to start. I apologize.
I could start. So today we are have some opportunity to demonstrate some very basic IOBs that Charlie's put together with some joint work that we've done that are very basic. These are indicators of behavior that reflect very generic network computer usage, such as number of bytes per day, number of packets per day, the number of TCP connections per day, the types of metrics that we think are important in a general behavioral presentation of the number of computers or processes or people or whatever in an enterprise can be quite extensive with hundreds of metrics, but we'll just look at some of the basic ones that I have used in enterprises and US government facilities successfully to find malware and to find insiders or some kind of not alarming, but some kind of behavior that is snaky or seems to be somewhat anomalous in an enterprise. Do I get to grab the screen, Charlie?
Absolutely. Were you looking to, you wanted to show a few things with Argus first to illustrate the idea?
Yeah, well, I don't have any Argus specific things. I was going to show something a little bit later. I'll talk about it and then I'll try to get some screens together. How long do I have? 15 minutes? 20 minutes?
Yeah, that 15, 20 minutes will work just great.
So in this project and in many projects that I've been involved in, we are using a tool called Argus, which is a tool that's been around for quite a long time. It was originally designed to be a network audit system for very large enterprises. It's been used in the NSF network. It's been used in many government networks. Many enterprises use it for core and backbone network awareness. It's one of the original NetFlow sensors, and but it's much more than what you see with NetFlow or IPFix or SFlow or QFlow or JFlow, all the alphabet flows as we used to call them. It's a system that's designed to extract as much network feature set as possible, because the idea was that you can't do packet capture. It's too expensive and it's just too much data. How can we create something of a concise summarization of what's going on in the network in a way that can be used for operations and performance analysis as well as cybersecurity. And so it has a lot of bells and whistles in it, but in this particular project, we're installing it on every in system in a small group. And then we're looking at very basic network behavior that an in system initiates, but it also observes while it's in the network. If everybody's familiar with NetFlow, I don't want to go into it too much, but with every network status report that we generate, it's based around network activity. So it has the classic 5 tuple identifiers, if that exists in the traffic, like source and destination addresses, the protocols, and the source and destination ports. But it also has a lot of metrics, like how many packets there are, how many bytes, the direction of the data, the interpacket arrival times, the packet size distributions, round trip times, the various encapsulation identifiers that are really important for understanding the scope of where this traffic is. Things like TTL, because that can be used to exploit certain things in the network. But it has about 250 metrics that are in each flow record that we generate. And each flow record should account for every packet. The collection of flow records should account for every packet that was seen on the network. There's nothing that's going to get by, at least some fundamental reporting. So from that, if we collect all that data and we store it and then start to analyze it, we can begin the process of creating anomalous behavior alarms and alerts around the basic metrics of network activity. So if we have about a month's worth of data, in our experiment, we keep around 6 months of data. We'll know what the average byte transmission per day is for every Ethernet address, for every IP address that we see, who's generating and who's receiving it. And when you have that kind of base information, you can be aware that this guy's sending a little bit more bytes than he normally does, which is the essence, I think, of what an indicator of behavior is. So behavior is pretty wide, pretty big. Many people are going to have many different opinions about what network or computer or personal human behavior is. But you have to start somewhere, and I think we've got a good grip on it. I was going to show you some of the data screens that we create. Can I do that, Charlie?
Absolutely, you absolutely may.
Yeah, let's see if I can share that. This is a presentation of just the Ethernet addresses in a small network that I have here in New York. It's a nice graphical presentation. It's each one of these bars represents a matrix representation. Ethernet A is talking to Ethernet B, and if I can slide this, you'll see that there are lots of them. There are 693 of them just from yesterday. And if I go to today, I'm going to click on this last block right there. And these are the ongoing Ethernet relationships that are going on in my little LAN right now. And as you can see, I have a lot of Apple gear. This is the list of Ethernet addresses. There are 44 of them. They have different classes. Most people don't know that Ethernet addresses have classes. These are the universally allocated address list right here. Those are the ones that have the vendor 3 bytes in front of every Ethernet address. The LM are the local multicast addresses. So that's a broadcast address. And when I click on it, I get to see the active broadcast relationships that are going on today. If they're green, that means that we have an awareness of them. We've seen them before. If they're blue, that means they're brand new, or they are new within the last couple of weeks. And this over here is our 182-day history of a particular activity. And if we can go over here and look at all of the different kinds of activities that we're tracking. So we can track the classes of Ethernet addresses, what countries these Ethernet addresses are involved in, what servers and clients are involved. We can even look at stupid metrics or simple primitive metrics like how many packets there are. And so this is the packet count for the broadcast address in my domain for the last 182 days. And we see that yesterday, this red right here is pretty hot. And this one way up here is not. So is that important? Well, yeah, it's a big change. Is it relevant to a cybersecurity situation? I have no idea. And the idea is that in many break-ins, especially with intractable, persistent threats, like Volt Typhoon type of break-ins, you have an adversary that is embedded in your infrastructure for a very long time. And it may be very difficult to understand what the purpose of a brand new behavior is that might come about from the activity of the intruder. So you do need to know, hey, all of a sudden this guy sent 4 million packets to the broadcast. Somebody sent 4 million packets to the broadcast address. Down here, we know who it was, which is really important to understanding that. Is that nefarious? Well, it could be. A lot of people have moved exfiltration data using broadcast addresses to do that. And so it's definitely something we would be interested in. But you're not going to understand the relevance of this particular indicator of behavior without some other supporting material. So if I go to this address, this Apple address, for instance, this is today. He hasn't been talking much to anybody. He has 2 days over the last 6 months where he's been pretty hot. This here is the in-degree local. This is how many other Ethernet addresses inside the LAN does this particular address talk to. So on the average, if you look at this right here, can you see this, by the way, Charlie?
We can see about 8.920.
Yeah, so this particular IP Ethernet address talks to 8.92 other Ethernet addresses in the LAN on a daily basis. And if you see today, he's talked to 8. If you see yesterday, he talked to 10. But on this day, he talked to 15. Is that an indicator of lateral movement detection, or is that an indication of an attempt to discover other Ethernet addresses inside a network? The interesting thing is he can't do those things without increasing the number of peers that he talks to. And now we've got at least the ability to see that he is talking to more than he normally does. And at least we have the list of addresses down here that he's talking to. And we know that 4 of them are brand new. He's never talked to these guys before. And let me see if I can grab them real quick. And this one, none of them seem to be very interesting because they're all, these right here, are all multicast addresses. But this guy right here seems to be important. So he does talk to that guy on a regular basis, but it's the style of talking is different and it comes up red on the same day. So that is an interesting one. We are going to need more information to understand, does this have a cyber angle to it? And I think, Charlie, you can talk to the rest of that. Does that sound good? Is that a good presentation?
I loved it. And I think that's a great setup for what we're about to show with how we would take these types of measurements and fold them into the indicator of behavior construct.
Yep.
So thank you, Carter.
Yep.
So what Kurt, Ali, and a lot of our team here at the Applied Physics Laboratory have been doing is we run a bunch of experiments here, but one of them has been setting up a small environment in our test arena where we've integrated in Argus as well as a few other endpoint logs and a few other tools to measure some activity across our network so we could generate a sample indicator of behavior. Now, I'd like to talk you guys through this. It's an extremely simple example that we wanted for today, but I'll share my screen and provide a little bit more context. And also will help. I want to take you guys through what's in this sample. It will be included eventually in our next update to the repository, but I'll talk more on that during our news and events for the project. But what I'm showing right now, for those that might be new here, indicators of behavior are machine readable formats that are extensions to the STIX, Structured Threat Information Exchange standard format. And what's very nice about STIX is while it is in a JSON format, it presents a knowledge graph of objects that have relations to each other, and each object has data and metadata inside of it. One way that we here at the lab really like to visualize and analyze that type of data is with a graph database. So I have a Neo4j representation of our indicator behavior up here, but really I'm starting with just a small portion. Just to remind everybody that this, which you'll see on your screen, you see about 4 multicolored dots with some lines between them. Just reminding you all that this is a knowledge graph, not quite a flow chart or anything like that. This is representing data objects and descriptions of how they're related. And to start with, here is one indicator of behavior that we have talked about some in our previous examples. This is when a computer shows a privilege escalation behavior. And essentially, this means that there's been some activity where a process at one level created a process at a higher level of privilege on a system. And just by that self, not the most enthralling thing, but we describe the behavior over here, and it has a mapping back to an attack pattern, which would come from the MITRE attack matrix, saying that this is related to this attack entry, but there can be a many-to-one relationship between attack and behaviors. The whole goal of behaviors, as many of you are familiar with already, is to have something that goes a little bit more in detail so that we can tie it to detection and correlation logic. And similarly, this behavior has a detection object, and I'll talk more about those in just a few moments. And the detection objects have a user relationship to a detector object. So for this small example, we are looking for privilege escalation activity, and we're sharing a detection analytic that's using Sigma format. And if we want to share it in Sigma format, we include the detector, so you can find out what Sigma is and how to get it. Now, this is just one little behavior. Our behavior bundles normally need more than one of these in order to help do a correlation. And so I mentioned we've been using Argus. So I'd like to expand this graph a little. And let's see what I can do here. And I'll expand it, and I'm going to clean it up just a little. So I'm going to hide these tan things are identity objects. So this is Open Cybersecurity Alliance's identity. I'm just hiding that for a moment to make this a little less cluttered. MITRE makes the attack matrix, so we keep a reference to them. The screen thing is a grouping object in STIX to help keep all the items together that we care about. And what I'll do over here, well, this is when I realize I should have put these guys out on the edges. But oh well, we will make all this. We'll hide that again. We'll make this try and make this a little cleaner. So, as I was saying, that sometimes we need more than one behavior in order to detect and correlate things, to actually say that we might see potentially malicious behavior. So I mentioned that privilege escalation, saying that perhaps we observed that occurring before a new behavior, which would be an internal system generating significantly more traffic than it normally does. And that could be tied to an Argus detection analytic that is using Argus. And say, what's Argus? Well, now we can look at here and say it's a type of detector the object was created by us, but it's the Network Audit Record Generation Usage System. That is a network detector. We say PCAP as the data sources that it pulls in. It's to generate traffic. We have a little CPE created to help people understand which version we used and where it came from, as well as links to the openargus.org website and the vendor quotient, so that one could go learn more about it and get access to the source code if they follow the links to the GitHub for OpenArgus. Now, so that's nice to let us know what the tools are. But as I said, we were sharing these detections, and we can translate and extract that data from our detection objects. Just for the sake of time, I have those up here in their Sigma rule format, where we can say, this right here is our detection for our secondary payload escalation, but also we have our simple detection analytic here for increased outbound traffic. Now, for today's example, this is a little bit of a simple analytic, but essentially what I'm saying is I see an increase in destination bytes as opposed to normal from an IP address. And I say abnormal increase in destination bytes from an internal IP address. And that's using the Argus product. And our detection here, we would have the source of, an Argus behave. Argus contains Z-scores, so we want to show ones that are greater than 20, that are filtering on the destination bytes field, because Argus can, as Carter was mentioning, will automatically generate alarms and alerts for any number of hundreds of fields when they vary from their norm by a certain Z-score and number of standard deviations from the mean. We want to find the ones that are ranking a little bit higher for the destination of bytes leaving, and we're going to find ones where they originated from an internal IP address, something in our 192.168. And those are good. That's a nice detection, but those that have heard me give this IOB talk many times is one of the points of IOB is the individual detections might have a high false positive rate, but that's why we also share correlation workflows which have a low false positive rate. That makes it a little easier to visualize that part, because the bundle also will include a correlation course of action that uses a playbook object. And this is some of the work that we have been doing with the Cacao team, for those that might be familiar with the Cacao standard for security playbooks. And that's a way that we can also embed our correlation workflows. And I'll show what that looks like for this example. I can copy that base 64 encoded string. And one of the sister projects in the OCA is Cacao Roaster to visualize and model and use Cacao playbooks. I will paste that in here real quick, and just need to get rid of that playbook bin text that I copied by accident. And I'll hit the import button, and this should bring up a correlation workflow. I might see if I can now, whether I can zoom or not is a. So the reason why we want to share multiple behaviors is my correlation set. I've already given these detections in that bundle. I would want to program those up into my SIEM or maybe an EDR, some tool that's going to process those different alerts. And my automation for this playbook or manually would be checking my alerts. And let's say we just had that first behavior I shared, the privilege escalation. And I could grab that by itself and say, did that escalation look like it was from a legitimate source? If it was legitimate, I'm just going to skip to the end of the workflow here. But if it wasn't, then I might make a record and say, assign a point for severity of this seems to be an abnormal privilege escalation event. And now I want to compare against my network traffic alerts. Did I have any? Well, if I had just that analytic, I wouldn't. So I would just say, okay, there was nothing else happening here. So I'm going to move forward. I apologize. I should have had an on false that got here as well. See if I can do that. Well, let's real time construction. Let's move that over. Okay. And because I'm a little OCD, see if I can. There we go. All right. So was there a privilege escalation? Well, no, there wasn't. So I'll go over here. I had that 1 point from the privilege escalation, nothing else. Is my point value greater than 2? No, it's not. I'm going to stop. But let's say that happened. And as I talked about in this graph, that happened before, and when we observed threat activity in the shared bundle, say that sometimes you'll see this before you'll see this. So now some time has passed, and this Argus detector fires. And that can start this shared workflow again. And now I can say, was an abnormal amount of traffic leaving the perimeter? And if it wasn't, I'll skip to the end. But if it was, well, maybe it's a potential exfiltration of data. And I'll add my 1 point. But now I'm going to compare against other alerts. And because this happened later, I can see that, oh, there was the privilege escalation alert back in the past. So now I've got that point and this point. I'm going to add one more, tally them up, and now I got 3 points for the privilege escalation, the data exfil, and the fact that the two were seen together on the same machine. And at that point, I can say, yep, I believe I've correlated some potentially malicious activity, and I want to contact my operator. And that's why we're looking at how to package up these type of more dynamically identified behaviors, because Argus, it wasn't pre-programmed to look strictly for destination bytes. It's looking for something that's different. And so we might have many, many of these types of dynamically identified behaviors, but we're showing how we would want to identify other behaviors that we correlate with it to say that something might be malicious. And for this month's example, we kind of did this simple case that we manually correlated ourselves. But I'm bringing this up because I wanted to talk a little bit about where we think, and Carter, feel free to chime in at this point if you'd like with me. I just want to talk about where we see this going, because it's nice to be able to show that we can have this data fit in the standard construct. But now that we know how we want data to fit into indicators of behavior, we probably want machines to help make some of these inferences and combinations and bundles on their own. I think would be kind of the next step. Would you agree with me on that?
Oh, absolutely. And we chose we chose this particular metric on purpose because it seems like it's an operations performance, just a network sort of thing. But it fits perfectly into the MITRE ATT&CK matrix in a number of places, but by itself, it's not an actionable observation, right? So it has to be associated with some sort of correlation. Now, Argus generates as many as 300 conditional anomaly indications. We haven't turned any of them into IOBs yet. So that, and to get the format correctly so that it fits into this sort of workflow is the most important part. The STIX format's probably the best way to do it. Okay, you get an increase of outbound traffic, but what else do you need to put in there to make it relevant and to be, digestible and things like that?
And that's where I think, just to kind of sound why so many of us care about data standards, is this makes it capable for the sensor developers to not just say, now I know a set of, I know a set of Argus, detections that I might want the machine to automatically say these together could be something bad. But we also want the machine to be able to understand, how am I going to describe that detection for someone that wants to look for it? And more importantly, Cacao gives us a standardized format for the correlation logic, which is really important if we're going to share this across the community, and extremely important if we want other machines to eventually be able to ingest this stuff and start doing it.
Right. So let me give you a couple of more examples of simple Argus indications that would be also need to be worked up in the same way. So for instance, we do keystroke detection. And so that just ends up being a number on this TCP connection. We saw 7 keystrokes. We have no idea what was keystroke, although we do have content as well, and we can find out what was keystroked inevitably. We're looking for some sort of indication that, whoa, maybe somebody ought to go look here and see what's going on. And the thing about keystrokes is, if you use Skype, Zoom, I mean, we're typing into the little message area, right? And that turns up as keystrokes. So you have lots and lots of keystrokes in your environment. But the trick is that through correlations, historical analysis, and context and scope, it can become extremely relevant. So if you're an ICS network and you've never seen a keystroke, well, if you see a keystroke, that's huge, right? We have simple things in Argus like port reuse indications. Somebody used the same 2 ports on a TCP connection within 5 seconds of the close of the previous one. Well, that's a problem. That's a violation of a protocol. What do you do with that? So you have to have a standard format and a nice data representation that you can consume this later on for correlation or for just to be an observable. And it's not just an operations metric. It's not just a performance metric. How do we turn it into a cyber metric? And I think this work is really important to enabling some of these basic metrics to turn them into actual support for cyber detections and indications.
Thank you.
Oh yeah.
Before we move on with some of our agenda, just wanted to check for a moment if anybody had some questions about what we were just talking about. I always take awkward silence as concurrence.
So you mentioned Volt Typhoon.
Yep.
Have you all seen the discussion in the CASP listserv
Yep.
about using Volt Typhoon for the next working session there?
Yep. In fact, that was going to be one of the big things I was going to. I'll move right into our news, Jane, because I have some thoughts on that. I know I haven't been able to make it to the last couple of CASPs due to, well, the last one I was in the middle of going to some doctors because I'm doing better, but I broke my arm right before the last one. It was a small break, but I was going through a bunch of urgent cares and X-ray facilities during the meeting, so I couldn't get there.
Yeah.
But I will say that Kurt, who's on the phone, and Ali on our team, we've been working on some indicator behavior representations of Volt Typhoon activity and doing some Volt Typhoon threat emulation in our environment. And so I was planning to bring that up to the discussion during the CASP call, that we might have a few things that we can share for the next CASP event that will be a little bit more representative of some of the things we've observed when we've tried to emulate Volt Typhoon. Because that's always, the translation to threat emulation is always a big tricky part. And I know about last month, we were trying to show some of the OpenTide work from the EU for the threat detection engineering piece of actually designing the searches. We're following their releases closely because sometime really soon, they're supposed to start having a lot more of those detailed examples that we can also, of how to use their platform to generate some of those examples. But for CASP, I think we'll have some Volt Typhoon data we can share with the group again, and that might be able to help folks out some.
I
So
can tell you that when we were first alerted about Volt Typhoon, I think a couple of years ago, I did some hunting and my hunt artifacts are up on VirusTotal. So if you have an
fantastic.
interest, I can send you the links to
I would love that.
my hunts on that. Okay.
Thank you. Another, well, I have everybody here. It just turned out to be a little serendipity right before the meeting. Another small announcement. I was able to get out on LinkedIn today. A couple meetings ago, we had demonstrated one of the tools that we've been using a lot is our fork of Jason Minnick's great little Stix modeler. That's a drag and drop GUI for creating Stix bundles. Because while I love showing these graph representations, Neo4j isn't the best place on earth to create. You don't really create your knowledge graph through this particular interface. And a lot of people build this stuff with Python, but that can be a big barrier for a lot of our analysts. And so I'm happy to announce that our Stix modeler fork is live on GitHub. For those here today, I'll throw that link in the chat, but will be in the notes also for this, that Jason Minnick a few years back made a really nice GUI, but he was focused more on like purely to spec Stix modeling. And a lot of our work requires extensions. So Kurt, Ali, and Hannah from our team really put a lot of effort into revamping the back end of the Stix modeler and allowing support for Stix extensions. And so now you can add any extension to a Stix object or any custom object and graphically build out your own bundles that you can export and the compliant Stix 2.1 spec, including generating all the needed extension definitions for sharing with other folks. And so we're really excited about being able to get this out the door and that it's now available for everybody. And just wanted to give that little, quick little preview of that piece for our community before I tell you a few more fun things. So, and so, yeah, the next thing I had on my notes was to talk about CASP, but also for those that might be tuning in, CASP is the Cybersecurity Automation Sub-Project. Duncan Sparrow and Brett Jordan and Jane are the leadership for that project within the OCA, where they host a series of automation villages where many of our open projects come together against a common theme and show how by embracing open standards and capabilities, we can rapidly integrate our development efforts together to serve a common purpose. And we had a really great event in April where I lost count of how many, but we had quite a few showcase the capability. And then in the final examples, I want to say somewhere around 8, I think it was up close to 8 capabilities that really hadn't done much work together, had been able to pretty rapidly go together for a scenario based on the 2018 Olympic Destroyer campaign. And we could rapidly start doing things like distributed hunt operations. And that was, I thought, really powerful because they were agnostic to any particular technology stack and still able to run. And as Jane mentioned, that sounds like the theme for the next one will be a Volt Typhoon theme. For those not familiar, Volt Typhoon is a massive campaign targeting U.S. critical infrastructure with living off the land techniques. And those can sometimes be a bit tricky to detect, which is why we've been looking at certain behaviors and how we represent those to be a little bit different than your traditional indicators, which tend to be IP addresses, domain names, and file hashes. We do these knowledge bundles because we think there's a little bit more mileage to get out of that type of detection. And speaking of trying to get more mileage out of indicators behavior is my other big piece of news. I'm happy to say that we don't have a press release for it yet, but we are well underway in designing out an operational pilot with a critical infrastructure member for the indicator of behavior, where we'll be able to test some of these concepts in operations. And I'm hoping by our next meeting, we'll be able to share the full release data for you. But we've been having chats with our sponsors here at APL, our sponsors at CISA, Cybersecurity and Infrastructure Security Agency, as well as certain members in U.S. critical infrastructure. And we found what we believe to be a really good partner that we're still fleshing out all the details, but we'll hopefully be able to do an operational pilot quite soon and have some very interesting insights to share where we actually try to utilize IOBs in some of our production defensive efforts and capture feedback on what some users might need for new features, which would be informing us to what other updates we might want to do with the standard, or even with some of the taxonomies and common knowledge that we want across all these different standards and capabilities. So we find that some pretty exciting news and really happy to share that with you guys at this meeting today. With that said, we have about 15 minutes left. I'm not trying to force the meeting too long, but I wanted to make sure I opened the floor to any general discussion points or questions that folks might have. So I'll stop talking for a moment and try to listen and see if anybody had any additional questions, comments, or concerns. I will take this silence as everybody is just so enthralled by the news that I've said that you're just speechless. You're all speechless and so excited. It makes my heart sing. So I'm glad to have that. Thank you, Jane. I see you on the chat. So I'd say if you just as a reminder, the listserv and the Slack channel for the OCA are the main places to get information on our developments in between meetings, as well as we will promote things on LinkedIn as we can. And just I thank all of you very much for your time, and I will stop the recording and see you all at our next meeting, which is scheduled for the second Tuesday in December at 1:00 p.m. Eastern Time. So with that said, allow me to find the stop recording, and we'll see you next time.